Hello students. So let's try to go for one more problem from IIT Jam 2021. This problem is from modern physics, and mainly we have to just use the Pauli exclusion principle and also the concept of three-dimensional harmonic oscillator. So the problem is very straightforward. There are 20 electron and we have to take spin into account. So there is a spin half 20 electron is adjusted into three-dimensional harmonic oscillator. So we have to calculate what will be the minimum energy when we are put all 20 electrons into three-dimensional harmonic oscillator with frequency omega. And all electrons are not interacting to each other. They all are not going to interact with each other. So we can assume that all they behaving just like as an independent one. But obviously we know that there is one constraint that's name is Pauli exclusion principle. What Pauli exclusion principle states that in every quantum state, there is only one electron can be adjusted. This is all about our Pauli exclusion principle. But what is quantum state here? Here quantum state are all possible degree of freedom. That means all possible quantum numbers. So here we will use the quantum number associated with the energy as well as associated with the spin. So let's see how we can approach this problem. So for the three-dimensional harmonic oscillator, the energy can be quantized by 3 degree of freedom in a Cartesian coordinate, and this can be written as nx plus ny plus nz plus 3 by 2 h cut omega. So this is the value of nx, ny, nz, and I can put nx is equal to 0, 1, 2, 3, and so on. Ny is equal to 0, 1, 2, 3, and so on. And nz is equal to 0, 1, 2, 3, and so on. But we can also write this particular statement as nx as en. That means n plus 3 by 2 h cut omega, where n can be written as nx plus ny plus nz, and n can be also varied from 0, 1 to 3. So this is the story of energy. If I am talking about given value of n, the possible value of nx, ny, nz are one particular energy state. And if we are accounting the spin half, then extra term will be there. That will be that 2 electrons, due to this spin half, we have 2s plus 1. That means 2 into half plus 1 number of degeneracy will increase. So let's first try to calculate all the possible degeneracy. Then we can easily calculate what will be the final configuration of putting 20 electron in this particular problem. So what I am going to do, I am just writing energy here, En, the value of n and value of nx plus ny. I can or set of nx, ny, or nz. And here we have degeneracy due to this energy, due to this set, number of possible set. And the actual degeneracy is 2 into gi. 2 is due to spin. So what I can say in one particular energy, we have 2 into gi number of electrons. So let's go for En is equal to, n is equal to first 0, then En is equal to 3 by 2 h cut omega, and here we have only one possible set is there. So it is non-degenerate state according to energy, but if we are taking a spin into account, then we have 2 into 1 is equal to 2. So that means in this state 2 electron can be adjusted. Let's go for 5 by 2 h cut omega. That means n is equal to 1, and here we have 1, 0, 0, 0, 1, 0, 0, 0, 1. These are 3 different values. So this one is one particular state, this one is another state, this one is another state. So there is 3 state, and here we have 2 into 3 is equal to 6. And similarly, we can go for 7/2 h cut omega for n is equal to 2. So we can have 2 0 0 0 2 0 0 0 2 1 1 0 0 1 1 1 0 1. So we can have all these 6 particular degeneracy. Due to spin, the degeneracy will increase twice. So there is 2 into 6 is equal to 12. Now, what is meaning of that? 2 electron will have this particular energy, 3/2 h cut omega. 6 electron will have 5/2 h cut energy, and this 12 electron have 7/2 h cut omega energy. So now we can find, and this is the configuration of ground state. This is the minimum energy occupied by the whole system. Whole system, if I am talking about 20 electron will put into this particular 3-dimensional harmonic oscillator, then this configuration will be the configuration of ground state. Let's calculate ground state energy. So we have 2 into 3/2 h cut omega plus 6 into 5/2 h cut omega plus 12 into 7/2 h cut omega. If you are going to calculate it, that will be, I think, 120/2 h cut omega, because 6 plus 30 36, and this will be 94. We have this particular thing, that will be 60 h cut omega. So this is a typical value of energy. So we have 60 h cut omega if we have 20 spin half electrons in the 3-dimensional harmonic oscillator. So it's a very nice problem. You should learn about what is meaning of degeneracy of energy, what will happen when the spin come into picture, then how number of electron is going to increase, then each and everything we can learn from this particular question. So you can easily solve this type of problem, and this type of problem is in trend of your examination. Try to solve it. What will happen when some fermions which has 3/2 spin, then how you can adjust? You can just try this particular problem. Thank you.